Hello guys, I welcome you all for the today's video. And today's video is about a AI concept that is an AI-based classifier for the sentiment analysis. And yeah, before getting into topic, I am Lakshmi Vaibhavi, currently pursuing BE in actually Venkateshwara College of Engineering. So today we'll be having a brief look up on this AI-based classifier. First of all, what is this classifier? So before getting into the sentiment analysis, so let me tell a few lines about this Naive classifier. This Naive classifier is generally, this is a family of algorithms or a group of algorithms based on the Bayes theorem. Despite of this Naive's assumptions of future independence, these classifiers are also widely used, mainly for the simplicity and efficiency in machine learning. Then and it's also easy to implement and its applications then the practical utility despite over the oversimplified assumptions. So this is the brief view on the Navies classifier. So as I said, Navies is a the collection of classification algorithms based on the Bayes theorem. It is not a single algorithms but a group of algorithms where all of them share a common principle, that is that every pair of features being classified is independent of each other. Like there is no similarities between the features on which you are going to classify. It's always a distinct feature we are going to classify. So introduction to sentiment analysis. Sentiment analysis is a computational study of opinions, sentiments, and emotion expressed in the text. So, by the utilization of the naives, we can efficiently classify these sentiments, providing a valuable insights for the business and researchers alike. So, this presentation you know, will see the methodologies and applications of naives in sentiment analysis. Um, Next is understanding the Navies. Navies is a probabilistic classifier based on the Bayes theorem. As I said, is a group of algorithms. It assumes that the presence of particular features of in a class is independent of the presence of any other features. Means it makes a classification between the two features which are distinct from each other. So this simplicity makes it particularly effective for the text classification task. And one of the application is sentiment analysis. So how sentiment analysis works? Basically, we are going to collect the data, then we are going to pre-process the data. Like we're going to extract important features in that, and we're going to split up the data like training data set and testing data set. Once we are done with the the splitting up of the data, we're going to build a model. Once the new ways model has been built, then we are going to analysis. We'll be making analytics on that model, like based on that confusion matrix. Like we are going to calculate the precision, accuracy, then recall and F1 scores. So based on the scores, we'll predict like how good the model is working. So as I said, process begins with the data collection, followed by pre-processing to clean and prepare the text. Next, we'll extract the related features and apply the naive algorithm to classify the sentiment as positive or negative or neutral. If it is positive, then we are going to assign the value as 1. If it is negative, 0. So this systematic approach also is, approach allows for effective data interpretations. Then applications of sentiment analysis. So sentiment analysis is widely used in various fields, such as mainly you can take the example of the social medias. So you'll be videos are recommended, right? Like once you watch one video, based on video, you will be recommended the videos which are related to the previous videos. So the same thing is uh, you know applied in marketing, then customer feedback and social media monitoring. Business utilizes this model insight to enhance audiences, then tailor the marketing strategies and gauge public opinion on products or the services. So, challenges in sentiment. Despite its effectiveness, sentiment analysis faces the challenges like sarcasm detection. context understanding, and language nuisance. These factors can lead to the misclassification, emphasizing the need for the continuous improvement in algorithms and methodologies. So the thing is, what are the assumptions of the navies? One is the feature independence, like the features of the data are conditionally independent of each other given the class label. Next is features are normally distributed. So it is a if a feature is continuous and it is assumed to be normally distributed within each class. Next is discrete features have multinomial distributions. If a feature is discrete and then it is assumed to have a multinomial distribution within each class. Next is features are equally important. Like you can't negotiate between the features. Like all features are assumed to be contribute equally to the prediction of the classes label. Next is no missing of the data. The data should not contain any missing values. Next, future of sentiment analysis. The future of sentiment analysis lies in integration advanced techniques like deep learning, NLP, means natural language processing. These innovations aim to enhance accuracy and handle complex sentiments, paving the way for the more sophisticated analytical tools. Next is conclusion. In conclusion, Navies offers a robust framework for performing the sentiment analysis efficiently. Its principles and applications, we can unlock the valuable insights that drive the decision making in various sectors, ultimately enhancing our understanding of public sentiment. So, thank you guys.